Okay, we are actually going to skip. We did 3, 1, 2, 3, 4. We're going to skip 3, 5, and 3, 6 and go to 3, 7. If you go on into pre-calc, you'll get the 3, 5, and 3, 6. So this will go in your notebooks for 3, 7. And this is another method for solving like 2 equations, 2 unknowns, 3 equations, 3 unknowns. And if you look back to that first set of notes that we did on 3, 1, it was solving systems of equations. We did like substitution, linear combination, and this is one of them, solving systems of equations using what they call Cramer's rule. Before we can go into Cramer's rule, you got to know a little bit of information first. First, on Cramer's rule, we're going to use what they call a determinant, and a determinant is just a value. So it's a number, and it's usually associated with what they call a square matrix, like 2 by 2s, 3 by 3s. They're a square matrix, so it's just a value. And they will give you problems that say evaluate the determinant, or sometimes they just say evaluate. Okay. An example, we're going to do a 2 by 2 first. I'm going to take you through a couple of examples of that, and then we're going to do a 3 by 3. And for a determinant you use just parallel lines. And if you listen, it's going to be easier to write it if you just listen instead of looking up here each time. And I will read the first row across, and then I read the second row across. So the determinant is 6, 4. Second row across is -1, 0. And you use just parallel lines, okay, on the determinant. Okay, and if you look up here, to find the value of the determinant, you multiply down the diagonal to the right. So you multiply 6 times 0 is 0. You subtract the product coming back up. So you multiply -1 times 4 would be -4. You subtract the product coming back up. So 0 minus a -4 just be +4. Okay, let's try another one. Try another one. Okay, first row across is -5, -5, 2. Second row across is 7, 4. To find the value of a 2 by 2 determinant, you multiply down the diagonal to the right. So you multiply -5 times 4, -20. You subtract the product coming back up. So you multiply these two, and you subtract that product coming back up. So -34. Okay, let's do one more. 2 by 2s. First row across is 9, 3. Second row across is -2, 5. Okay, 9, 3, -2, 5. So to find the value of a 2 by 2, you multiply down the diagonal to the right, 45, subtract the product coming back up. So minus a -6, so it'd be 51. Enough examples on a 2 by 2? Okay. You multiply down the diagonal to the right, subtract the product coming back up. Okay? Okay, now, we're going to take and use the determinants to solve 2 equations, 2 unknowns by what they call Cramer's rule. So the directions will just say use Cramer's rule to solve. And we're going to do 2 equations, 2 unknowns. Okay. First equation is 5x plus 4y equals 28. 5x plus 4y equals 28. 3x minus 2y equals 8. Okay. Now, let me explain on Cramer's rule. Cramer's rule, we're going to solve by having an x, a determinant in the top, a 2 by 2, and a determinant in the bottom. The determinant in the bottom is always these four coefficients. Okay? So in the bottom, we're going to have 5, 4, 3, -2. Okay, and that will be in the bottom for both x and y. I really should have my x. I really probably should have the x down here in the middle. That's that one determinant divided by another one. Okay, if, everybody watch up here for a minute. If you're solving for x, okay, you're going to put these two constants in for the x coefficients and put them up and down. So this is going to be 28, 8. And then the y stays as 4, -2. So if I'm solving for x, I replace the x coefficients with the two constants. Okay, now you figure the value of both 2 by 2's. So multiply down the diagonal to the right, -56, and subtract the product coming back up, -32. So -56 minus 32. Right? Because they're both negative. That's all right. They're both negative. Okay, and then multiply down the diagonal to the right. -10, and subtract the product coming back up. So -22, and -88 divided by -22 is 4. So our x value is 4. Okay, now let's do the y's. Okay, to do the y. Now, think about it. Once you're still going to have two determinants, but isn't the bottom determinant going to be the same? Yes, so you already know the bottom is -22. You don't have to work it twice. Okay, so now when you solve for y, you're going to put these two numbers in for the y coefficients. The x coefficients are the same. Replace the y coefficients with 28 and 8. Okay, the x coefficients stay the same. Multiply down the diagonal to the right. 40 minus.
So why is y?
The bottom. This bottom is the same on both columns. It's the coefficients of all four. I could write it out.
Oh.
But it's going to be the same. Why work it twice? Yeah. Okay. Okay. So the top, we got 5 times 8 is 40 minus 84 over -22. 40 minus 84, -44 divided by a -22 is 2. So our x is 4, our y is 2. And Cramer's rule is actually one of the easiest methods to solve 2 equations, 2 unknowns. I don't know why they don't start with that, but okay. Let's do another example. So let's do another 2 equations, 2 unknowns. Okay, so let's say they give you 3x minus 5y equals 25. 3x minus 5y equals 25. 6x plus 4y equals 22. Okay, if I want to solve for the x, I'm going to have two 2 by 2's determinants. Okay, the bottom is just the coefficients of the x and the y. So it's 3, -5, 6, 4. The top, if you're going to solve for x, you put these two constants in for the x. So we're going to have 25, 22, and then the -5, 4 stays the same. Okay, let me stop there. Now figure the 2 by 2's. Okay, so multiply down the diagonal to the right would be 100. Subtract the product coming back up. Multiply 22 times 5. Okay, subtract the product coming back up. Okay, so that would end up to be 210 on top. Multiply down the diagonals to the right. 12. Subtract the product coming back up. So that would be 42. 210 divided by 42 should get 5. So your x is 5. Okay, now let's do the y. Okay, now this is where I could write that same. I could write the same bottom part, but do I need to work it twice? No, I know what the bottom part is. I know it's 42. As long you have to be very careful you don't make an arithmetic error. Okay, so now if I'm solving, if I'm solving for y, I'm going to put these two in for the y's. Okay, so my 2 by 2 up here, the first column is going to be 3, 6, 25, 22. Okay, multiply down the diagonal to the right, 66. Subtract the product coming back up, 150, and you should end up with a negative 82 over 42 to negative 2. So our ordered pair.
That would give 84.
Oh, sorry, 84. That's my fault. But it still ends up to be negative 2. Sorry, I looked at the wrong thing. Okay, so you end up with 5 for the x, negative 2 for the y. And you should be able to check it back in both equations. It should work in both equations. Okay? Okay, that's 2 by 2's and a 2 equations, 2 unknowns. Okay, now I want to take you through 3 by 3 determinant. Okay, and the way they will write this is they'll say it's like a 3 by 3. Find the value of a 3 by 3 determinant, and it's just going to be a number. You could work 3 equations, 3 unknowns by Cramer's rule. Okay? So, we're just going to do the 3 by 3 determinants first. Okay, a 3 by 3. Same thing, it's going to be easier if you just listen and write it down as I read it. First row across is 4, negative 3, 7. Second row across is 3, 1, 5. Third row across is 6, negative 2, 6. Okay, double check it. First row is 4, negative 3, 7. Second row is 3, 1, 5. Third row is 6, negative 2, 6. Okay, there's multiple ways to work 3 equations or 3 by 3 determinant. I'm going to show you one. Okay, what you do on this method is you repeat the first 2 columns on the outside. So take this column and you repeat it, and you want to line them up. Okay, so your handwriting is important on this. You want to write them up. So line them up. Okay, repeat the first 2 columns on the outside. Columns go up and down. Okay, so you're repeating the first 2 columns on the outside. Okay, in this method you multiply. In this method you multiply down the diagonal to the right. So we're going to multiply. And I recommend you draw the arrows. They should line up. So 4 times 1 times 6, 24. Multiply down the diagonal to the right. Negative 15 times 6. Negative 15 times 6. Negative 90. You add the products coming down to the right. So add a negative 90. Multiply down the diagonal to the right. So 21 times a negative 2. So add a negative 42. Okay? Everybody caught up? Okay, then start in this lower, start with the 6. You're going to multiply, coming back up. 6 times 1, 6 times 7, 42. Listen, you subtract the products coming back up. You multiply and add the 3 products coming down to the right. You subtract the 3 products coming back up. So subtract 42. Multiply coming back up. Negative 2 times 5 would be negative 10. Negative 10 times 4, negative 40. So subtract a negative 40. You subtract the products coming back up. 6 times 9 would be negative 54. Subtract a negative 54. Okay? And then you simplify all that, and you should get, I ended up with a negative 56 for the final answer. And you can use your calculator on that part. So the main thing is you multiply down, and you add the diagonals going to the right. You subtract the products coming back up. Okay? Okay. Last example. Okay. On this one, same thing. Listen and write it down as you hear it. First row across is 3, negative 6, negative 3. Second row across is negative 5, 4, negative 5. Third row across is 2, negative 1, negative 5. Okay, double check it. First row is 3, negative 6, negative 3. Second row is negative 5, 4, negative 5. Third row is 2, negative 1, negative 5. Okay, now you try it. Okay, let me finish this. Okay, so on this one, if you multiply down the diagonal to the right, you should end up with a negative 60. Oh, wait a minute. I forgot to write those out. Sorry. I need to copy these. You repeat the first 2 columns. Okay, now multiply. You end up with a negative 60. Multiply down the diagonals to the right, and you should get 60. Multiply down the diagonals to the right, 15, plus a negative 15, right? Negative 15. And then subtract the products coming back up. So minus a negative 24, minus 15, minus a negative 150, and final answer 144. Okay. And you guys thought this was hard at the beginning. Yeah. Oh.